All right. So, Mr. Neal made a couple rookie mistakes last video, so let's go see if we can catch them. The first rookie mistake that I made was we did all this great work, but the very first question we forgot to fill in the range of this function. We alluded to it at the beginning, but at the beginning we said if we can just find this minimum value, we'll know that the range goes from low to high, right? And so the range is the lowest point up to infinity, and it took us a while to find the lowest point, but eventually we found that it was -1/4. So the range is from low to high, -1/4 to infinity is the range. Remember, range are y values, so we would come here -1/4. If you write -0.25, that's also fine, right? Typically, I'll use fractions just because, and we're going to see this a lot this year. They're a little bit easier to work with, believe it or not. Okay, the second rookie mistake that I made was in part C. We found the minimum value to be this point here, -1.5 comma -1/4. So I'm going to actually erase a lot of this. Whoa. Whoa. And it did nothing. Awesome. So take two. I'm actually going to erase a lot of this. Whoa. Whoa. Okay. So let's remember, we found this point right here on the graph was the lowest point. That was the point -1.5 comma -0.25. That was that lowest point on the graph. And technically, if we're going to be writing maximums and minimums, then we need to write it in a specific way. Is that the color? Close enough. We need to write it in a specific way. So sadly, it is not enough just to write the lowest point. I'll know what you mean, but if we're going to write out the minimum value, we have to write it in a specific format. And the format goes as follows. Y when x equals blank. Okay? So the minimum value, so let's put some numbers into this template. The minimum value is the y value, -0.25, when x equals -1.5. This is technically how we need to be writing our maximum and minimum values. Okay? Y when x is blank, or in this case, the y value, -1/4, when x is -1.5. So y when x, okay? That's how we're going to write the minimum value. We would write it the same with maximum. So if the maximum was at a specific point, we would say the y value when x is blank. Okay, and we'll see that in some coming examples. Okay, I think those were the only two massive, enormous, catastrophic mistakes that I made. Okay, so now we have the issue of not doing that. How do I erase literally everything? Is there a... Guys, ugh. Okay, forgive me. Oh, I get it. It, like, deletes the highlighted stuff and then delete... Oh. Okay, that makes sense. Okay. All this goo can go away. Okay. I'm sure that was super engaging for you guys. Example number 2, which we are going to do in class together. So we're not going to do that in this video, although I do want to show you what example 2 looks like. If you graph the function square root x squared minus 4, you get the following image. Pretty crazy. So this is the image we're left with. and we're going to look in class about any increasing, decreasing intervals, all the stuff from parts A through E. Okay? But if you want to get a head start on that problem, by all means. Let's do 3 through 9 here. The first example, example 3, says find f of 1. F of 1. Well, if we had the formula, we remember from lesson 1.2 that to find f of 1, you're basically saying, okay, when x is 1, what is y? And that's the same as true here. When x is 1, so here, that 1 on the inside, that's x is 1. So when x is 1, then what does y equal? That's what this question is asking. On the graph, when x is 1, what is y? Let's find out. So if we come over here, it's not very difficult to see that when x is 1, y is 2. When x is 1, y is 2. So f of 1 is 2. F of 1 is 2. Cool. Question 4. Find x when f of x, this should not be cut off, equals, let's do 1. Find x when f of x equals 1. So this is a different question. In this example 3, we were told that x was 1 and asked to find y. So here we said f of 1 equals 2, right? In this example, we are given the y value and asked to find what values of x make that true. So we are looking for where is the y value 1. Here there's a height of 1. Here there's a height of 1. But there are other places where the y value is 1. For example, here, here. So there's several places. If you plug in a -1 in for x, you get out an answer of 1. If you plug in a 2 in for x, you get out an answer of 1. And if you plug in a 4 in for x, you get out an answer of 1. Cool. And I was just kind of eyeballing those things. So for x equal -1, 2, and 4, f of x is 1. State the intercepts. So in example 5, we were asked to state the intercepts. Well, how many intercepts are there? Notice it doesn't say state the y-intercept or state the x-intercept. It says state the intercepts, and there are 2. There's one x-intercept and one y-intercept. The x-intercept and the y-intercept. Remember, intercepts are points on the graph. So the x-intercept is here at the point 3, 0. 3, 0. If you write x equals 3, even though I would know what you meant, you technically didn't write the intercept because you didn't write it as a point. X, y. What's the y-intercept? The y-intercept is here at the point 0, let's say 1.5. 0, 1.5. Okay, awesome. State all extrema. So extrema is a fancy word for maximum or minimum values. Extreme values are the extremely high or extremely low. State all extrema is saying state the maximums and the minimums. And in this example, there are several maximums and minimums. So let's see if we can't find them all. When we talk about extrema, there are the following possibilities. There is something called an absolute maximum and an absolute minimum. there is also something called a relative maximum, sometimes called local maximum, and a relative minimum. Okay? Absolute maxima and minima, maximums and minimums, are the literal highest or the literal lowest point. Relative is just high or low depending on what's around it. So let's see if we can't find the absolute maximum point of this graph. And the absolute maximum of this graph doesn't exist. Why does the maximum not exist? And that goes back to kind of our definition that absolute maximum is the highest point. And for this graph, there is no quote-unquote highest point. It just goes up and up forever. If any one of you ever tried to say, hey, I found the tallest point, everyone else would say, well, no, you didn't, because there's an even higher point. There is no absolute maximum because it just goes up forever. But is there an absolute minimum? And the answer is yes. There is a lowest point of this graph. Right? The lowest point on the graph is the point 30. But remember from the very beginning of this video, how do we write maximums and minimums? Well, it's y when x is, I deleted it, dang it. It's y when x is blank. So in this case, the y value, 0, when x is 3. 0, the absolute minimum is 0, and that occurs when x is 3. What's the relative maximum? I think we would all agree that the relative maximum, at least considering points around it, kind of the peak or the valley, in this case the relative maximum would be the peaks, and there's only one peak, and it occurs at the point 1, 2, but how would we write it? Y when x, so the relative maximum is 2 when x is 1. Y when x is blank. And then finally, the relative minimums. Why do I say minimums? Because there are two. Here's a relative minimum, and this is a relative minimum. So absolute minimums can also be and are also relative minimums. So there's actually going to be two statements here. The first one we've already written, 0, while writing, 0 when x is 3, and this minimum, which is 1 when x is negative 1. Y when x is blank. So 1 when x is negative 1. These are the extreme values. Awesome. Intervals of increasing and decreasing. So I'm going to delete this for a second. Or not for a second, for all time. Oh no. Okay, where is it increasing? And for this, let's maybe go to our color. Well, it's increasing over this space and over this space. Why did I say that? Well, look. Certainly we would all agree that if you looked at just this section of the graph, it's rising. And if you looked at just this section of the graph, it's rising. But we want intervals of increasing. So we want to talk about the section of the x-axis over which that function is rising. And it's rising from -1 to 1, and then from 3 to infinity. So I'd write that as an interval from -1 to 1, and from 3 to infinity. You may remember how we want to join these, and that was with a big U for the union of these two sets. Awesome. Okay. A similar story is going to happen for the decreasing sections. Again, visually it's pretty clear that it's decreasing over this space and this space, but we want x-axis. So it is decreasing from negative infinity up to here at negative 1. Negative 1. And from 1 to 3. Okay? These are the sections where it's decreasing. So if we refer to the x-axis, negative infinity to negative 1, union 1 to 3. Awesome. All right, last question here is to state the end behavior. End behavior. So let's look at end behavior. Here's how we're going to write end behavior. You may remember in Algebra 2 writing this as x approaches infinity, y approaches, and then you gave an answer. And as x approaches negative infinity, y approaches, and then you gave an answer. Okay? So what are the answers to this? Well, this here we would call the right end behavior, and this here we would call the left end behavior. Why right and why left? Well, as x goes to positive infinity, that's way out there on the right. Like here's 3, here's 5, so then where's x equals infinity? Way out there on the right side of the graph. Okay, so then why is negative infinity the left side? Same idea. Way out there is negative infinity, way left. Okay, so that's usually how I think of it. I think as x approaches infinity is asking what's going on the far right of the graph. As x approaches negative infinity is asking what goes on the far left of the graph. And it's pretty clear to see that on the far right of the graph, when we're way out there, this graph is just going to be way up there at a y value of infinity. Okay. What's happening on the far left? Well, on the far left, same idea. No matter how far left I go, this graph is just going up and up and up and up to a height or a y value of infinity. Okay. So this is how we wrote in behavior in Algebra 2. How do we write it in actual math? Pre-cal. It's going to communicate the same ideas, but we write it a little bit differently. So let me show you how we write it. We write the following. If we want to talk about our right in behavior, we write this. LIM for the limit. Underneath that we write as x approaches infinity of f of x equals, and then we're going to fill out an answer. Here for the left in behavior, we're going to write x limit as x approaches negative infinity of f of x equals, and then we're going to give an answer. So let's look at the comparison. These are going to say the same thing. So what you wrote last year in Algebra 2 was this. Okay? What we write this year is this. They're communicating the same ideas. So this top statement is talking about the right side as x approaches infinity. You can see that those are the same. That's nice. And this will be talking about the left side. Okay. Again, x approaches negative infinity. Cool. So then in the notation, as long as you remember the LIM above the x arrow infinity, the limit as x approaches infinity of your function f of x is equal to whatever answer you gave earlier, infinity and infinity. This is the correct way to write end behavior in my class. The limit as x approaches infinity of f of x is infinity, and the limit as x approaches negative infinity of f of x is infinity. This is how we write in behavior. Unfortunately, even though this is, they say the same thing, this is poor notation. Okay, so we will end the video. In the next video, I'm just going to do A, C, and D, and then we'll be done. 11 and 12, we're not going to look at in today's videos. We'll look at later in the unit. So it's not that you're not responsible for this material, you're just not responsible for this material yet. Here in a couple weeks you will be, so if you want to come back to this, great, but we're not going to do this today.